so in this lecture, we're going to be speaking about differentiation. So let's go ahead and get started. We will introduce one of the basic concepts of calculus, which is differentiation. In other words, the derivatives. The concept of the derivatives as a mathematical equivalent of instantaneous rate of change of a physical quantity was formally introduced in the middle of the 17th century, independently by Newton and Leibniz. So a derivative is a rate of change of a function, and it can also be the slope of the line tangent to the curve. So if you have a curve and there is a tangent line, so the single point of intersection is this point right here, and this line can basically be determined by this equation. So if you have 2 points of this line and a line intersecting these 2 points, you have your x, so this distance is f of x, and if you have a, then this part is f of a. So the slope of a closer second line that goes here is basically can be determined by the derivatives. So as it goes closer and closer to this point, you have so many second lines. So we need to watch this slope right here. So it goes closer, closer, and closer. Then this is the point right there where it touches this point. So watch what x does. So as x approaches here, you have so many points right there. So as x approaches to a, you basically would see that the slope of the second line gets closer and closer to the slope of the tangent line. And it translates to this equation for the limits as x goes to a, which is the limit from x to a, which gives us the exact slope of the line tangent to the curve at a. And this is the equation of the slope. Another example can be shown here is the quadratic parabolic function, which is y is equal to x of squared. So we want the slope for a is equal to 2. So as x approaches to a, it is equal to 2. So as h approaches to 0, and this is this equation. In conclusion, the derivative is the slope of the line tangent to the curve evaluated at a point. It is a limit, which is 2 ways to define it. Once you learn the rules of the derivative, you will definitely forget all these limits and definitions. And therefore, we will go through the formulas and the equations right away for the derivatives so that you do not have to know all the limits and the back theory behind it. For the basic rules of the derivative, the basic rule is if you have the derivative function, it's dy over dx is equal to r, which is the exponent x to the power of r minus 1. So again, if you have the rule ax to the power of n, so dy over dx, it is the n, a times nx, to the power of n minus 1. Then you have here the f of x is equal to x to the power of 5. So dy over dx, it is 5x to the power of 4. Then you have the constant multiple rule. So that's the first rule. I'm going to also be explaining it in details. If you have k times the f of x derivative, it means that you multiply by k f of x. Then you have the sum and the difference rule. So f of x plus g of x derivative is equal to f of x plus g of x. Then you have another formula, which is f of x minus g of x derivative is equal to f of x minus g of x. So then you have an equation, which is ax to the power of n. So it is an x to the power of n minus 1. So find dy over dx. So when similarly you have dy over dx equal to 0, and solve for x and substitute it in the first equation to get y. To determine its nature of stationary point, we use also the second derivative. And if it's less than 0, it's a maximum, and if it's greater than 0, it's a minimum. And if the first one is not equal to 0 and the second derivative is less than 0, then it's the point of inflection. And if you also have the d squared of y over dx squared is equal to 0, then it's also a point of inflection. All right, so the first rule I would like to discuss is called the product rule. So it is f of x times g of x derivative is simply equal to the derivative of f of x function times the g of x as it is, plus your f of x function times your g of x derivative. As you can see here, like here it's taking the first function, and in the second part of the equation, it's taking the second function as a derivative. All right, so this is how you can remember it. The second rule is the quotient rule, and I'm going to be also explaining it in details. So it is your f of x function derivative times your g of x without a differentiation minus f of x times your g of x derivative divided by the g squared of x. So then we have the logarithmic rule. So e of x is e of x, a of x is equal to ln a of x. Then we have ln x, which is 1 over x, and logarithmic of a of x is equal to 1 over x ln a. All right, then we have the trigonometry. So we have sine of x is cosine of x, cosine of x is minus sine of x, tangent of x is equal to sec squared of x. Then we have the inverse. So the inverse of sine is equal to 1 over square root of 1 minus x squared. Cosine is the inverse, which is minus 1 square root of 1 minus x squared. Tangent is equal to 1 over square root 1 plus x of squared. So then we have the derivative of products and quotients. As I mentioned, the product rule is the one I explained to you, that you take the derivative of the first function times g of x plus the f of x times the derivative of the second function. So here you have an example, which is x squared times 3x minus 4. So x squared as it is, 3x minus 4 plus x of squared times 3x minus 4, again, the derivative of the second part of the function. Then we have the quotient rule, which is f of x divided by g of x. So it is derivative of the first part, upper part, divided by g of x. So f of x times g of x, but it's f of x times g of x divided by g squared of x. Then we have the quotient rule. Again, so we're following the same formula. So you have your x, f of x is x, and your g of x is equal to x plus 2. So again, you simply do the derivative of the first function times g of x minus the derivative of the second one times your g of x divided by your g of x squared. Then we have the chain rule. So we will learn to find the derivative of a composite function. So let f of x and g of x be functions, the derivative of which exists. Then the derivatives of the composite function h of x is equal to f of x is this one, which is f of x is equal to f g of x times the derivative of your g of x. So as illustrated in the previous example, in order to find the derivative of a composite function, we first need to identify its exterior and interior functions. Then roughly speaking, we compute the derivative of the exterior function while the interior function is left alone. And we multiply the result by the derivative of the interior function. So we need to find the derivative h of x is equal to 4x minus 1 cubed. So the function h of x composite of two functions, the exterior, which is x cubed, and the interior, which is 4x minus 1. So applying the chain rule, it is simply you need to find the derivative of your f of x, also 3x squared, and your g of x is equal to a 4. So you simply apply it, which is f of x times g of x, which is 3 times x g of x squared times your 4, which is 3 4x minus 1 squared times your 4. All right, then we have your example C, find the derivative of k of x is equal to sine ln x. So your f of x sine of x, your g of x is equal to ln x. So again, we simply apply the rule, which is the derivative of your f of x. So it would be sine of x times your g of x. So it would be the same times your g of x derivative, which is 1 over x. All right, and then you simplify it. Okay, so make sure when you do the composite functions, you just need to determine your f of x, g of x, and basically do their derivatives and apply the equation. As simple as this. The last part, we have the higher order derivatives. So the derivative f of x of a function is also a function. Then we may consider the derivative of the function f of x is called the second derivative, which is f denoted by double dashes. So some equations, especially in physics, they need you to do second derivatives and then maybe also substitute like some numbers in there in order to find the second derivative of the function. So an example here would be 6x to the power of 4 minus 3x cubed plus 5x squared minus 7. So we need to find the first derivative, which is 24x cubed minus 9x squared plus 10 of x. So you would need to basically simplify this to the second derivative, differentiate it to the second derivative. So it would be 24 times 3 minus 9x squared plus 10 of x. So it would be 72x squared. 9 times 2 is 18x, and plus 10x, the derivative would be 10. All right, these are also other examples. Same idea. So if you want to do the first derivative, you have to multiply 3 times 2 is 6x. 2 minus 1, it would be 1 to the power minus 4x to the power of half. So you multiply 4 times half is 2x, and half minus 1 is a negative half. All right. So then we have another example, which is x over x minus 2. So here you just simply apply the quotient rule. So you know that your f of x is x and your g of x is x minus 2. All right, so it is 4 over x minus 2 squared. Then we substitute 4 for x and we obtain 8 over x 4 minus 2 cubed is equal to 8 over 2 cubed, which is negative 1.